Today we're going to talk about factoring by grouping. Now you're only going to do factor by grouping if the following exists. The terms, there are 4 more terms. Terms have common factors that can be grouped together. And there are 2 common factors that are identical or the additive inverse of each other. So the additive inverse, y'all, is just like the opposite signs, which we'll get to in just a second. So the steps, the first thing we're going to do is we're going to group terms with common factors. Okay, so what we're going to do here is, I'm going to get my pink pen. We're going to group this and this. Now make sure you add in that plus sign to this one. Okay? All right. Make sure you add in that plus sign. Now what we're going to do is we're going to factor the GCF from each group. Okay. So this is where the whole scratch paper comes in. If you use it over, if you're going to have scratch paper on your homework. What we're talking about with factoring the GCF, well, the first thing I'm going to do is I'm going to factor 4QR. And then I'm going to factor 8R. Okay? So if I factor this, 4 is 2 and 2. So I have 2 times Q times R. And over here, 8 can be factored into 2 and 4, 2 and 2. 2 times 2 times 2 times R. All right? So now what do I have in common? I have a 2, another 2, and an R. Okay? So your GCF on this one is going to be 2 times 2 times R, which is 4R. Do you see that? Okay, so watch. I'm going to pull out 4R. What is left in that parentheses if I pull out 4R? If I pull out 4R from this, what's left?
Q.
If I pull out 4R, what's left here?
4.
If I pull out a 4R, what's left?
4.
Watch. If I pull out my GCF, what's left? If I pull out my GCF, what's left? Q plus 2. What is left? If I pull out my greatest common factor, what's left of the first term is a Q. What's left of that second term is an R. Do you see that? Okay. So now here, let's look at 3Q and 6. Well, this is just 3 times Q, correct? 6 can be factored into 2 and 3, so I have 2 times 3 times nothing, just 2 times 3. So what can be pulled out? A 3. So I'm going to pull out a positive 3. What's left? Q and a positive 2. And make sure you keep it in order. So what was left here? If I pull out a 3, Q. If I pull out a 3 here, I have 2 left. Why? Let me tell you why. Does somebody have a pencil? Can I see your pencil real quick? All right. Let me show you why this works. Distributive property. If I were to distribute this back across, okay, look. 4R times Q is 4RQ. 4R times 2 is plus 8R. Does this match that?
Yeah.
That's how you're getting that, okay? Now, once these two match, the grouped terms match. Do you see how they're both Q plus R, or sorry, Q plus 2? It's very important that these match. So what I want you to write, I usually write it over here. Let's do it over here on the side here. It is important that these be the same. It is important that those 2 parentheses are the same. Okay? When those 2 parentheses are the same, we can rewrite it as 4R plus 3. That's 4R plus 3 right there, my GCFs, right? And then I have Q plus 2. Now, let me show you something that's neat about this. I gave you a problem like this, how would you solve it?
You would distribute foil.
Foil. So watch. First, 4r cubed. 4r cubed. Outside, plus 8r. Inside, plus 3q. Outside, plus 6. Does that look familiar to anything? This and this, do you see how I'm doing the same thing? This is the extended version. This is the simplified version. So factoring, when you factor, you want to get it down to where you have a binomial times a binomial. Okay? Now, what's the trick? Well, if you take a multiple choice test, everything looks like a binomial times a binomial, so you just FOIL it, and you can always get back to your original answer. Do you see? Does everybody see how I've gone back and forth between all of these? Yes or no?
Yeah.
Okay. So let's look at the next one. All right. So let's put our parentheses around Rn plus 5 and negative R minus 5. Okay. What can I pull out of Rn plus 5 in? N. So I'm going to pull out an N. That leaves me with R plus 5. Right? Now, what can I pull out of this one? Now remember, we want our parentheses to match. Well, I have R plus 5, and I have a negative R minus 5. So what can I pull out to make that an R plus 5?
Negative 1.
Negative 1. So I'm going to pull out a negative 1, and I have R plus 5. They both match. We're good. So now we just write our binomial times our binomial. N minus 1 and R plus 5. And that's factoring by grouping. Okay. Now we have one more. Let's do one more. Okay. Number 3. So let's pull. If you want to go ahead and work ahead of me, go for it. If you want to pause the video, and then you can see if you have the correct answer in a minute. So I'm going to put my parentheses and make sure you include this negative 4 inside your parentheses. Now, if you need to, on the side, I want you to factor. This is 3 times n times p, 3 times 5. So 3 times 5 times p. What can I pull out? Let's just circle them. I can pull out a 3 and a p. So my GCF is 3 times p, which is 3p. So my first one, I'm going to pull out a 3p. Well, what's left is an n, because look, I have an n left there and a 5. N plus 5. Now, if I have n plus 5 here and I want this to be a positive, I'm going to pull out a negative 4. That's my GCF, and then I'm left with n plus 5. These match, so I have 3p minus 4 and n plus 5. Are we good? Okay. So let's talk about factor by grouping with the additive inverse. Now the additive inverse, y'all, that's just the negative. So if you look right here, it says, let's use the example. If you have 6 or k minus 6 and then 6 minus k. Well, what happens is we have a minus sign, but the negative is going with the 6 here, and the negative goes with the k there. So those are not the exact same term, are they?
No.
Okay. So if we have k minus 6 and 6 minus k, what we're going to do is we're going to pull out this negative 1 in this second term. Okay? Because if we pull out a negative 1 times 6 is negative 6. Negative 1 times negative k is k. Do you see that? So now my negative belongs to my 6, just like in this original, and they match. All right? Do you see that? Okay. So the first one here, if we do, I'm only going to do one example of these. 2mk minus 12m plus 42 minus 7k. So let's group these together. So if you have that second part, y'all, you can just take that part out right there, that number 2. All right. So let's factor. What can we pull out? Do y'all mind if I factor down here? 2mk, 12m, 42, and 7k. So I'm going to factor all these down here. So this goes to 2 times m times k. 12 is 2 and 6 and 2 and 3. So 2 times 3 times m. So my GCF on this one is 2m. My GCF right there is 2m. Now pay attention to what's left over. K and 2 times 6, or 2 times 3, which is 6. So we're going to go up here and we're going to pull out 2m. That leaves me with k. But this is a negative, so we're actually left with a negative 6. Are y'all okay with that? Okay. Now over here, if you factor out 42, let's factor 42. 2 and... Y'all can talk. 2 and what? 21. 21 can be factored into what?
7 and 3.
7 and 3. Okay. And then 7, is it a prime number?
Yeah.
So this is just 7 times k. So the only thing we can really pull out is that 7, can't we? Now what's left over? 2 times 3 and a k. So let's go up here and let's pull out our 7. So plus 7. That leaves me with 6. If you pull out a 7 from this, that leaves me with a negative k. Now, do you see how we have k minus 6 here, but we have 6 minus k here? We want to make the second one match the first one, so what am I going to do? Pull out a negative. So we leave this the same. Now let's pull out a negative and pay attention. If you were to distribute, negative 1 times 6 gives you what?
Negative.
Negative 1 times negative k gives you what?
Positive K.
Whoopsie. Positive k. Now, I have the same thing, right? My negative belongs to my 6. Excuse me. So you have 2m, k minus 6. Let's just, what is 7 times negative 1?
Negative 7.
And then I'm just going to rewrite this k minus 6. Well, now they both match. And when they match, we can write our binomials, 2m minus 7 and k minus 6. If I want to double check that I did that correctly, what would I do? What would I do to that answer if I wanted to double check to see if I did it correctly? Foil. We would foil, and if you foil, you should come up with this answer right there. Okay? This next part you're going to love.
You got sarcasm, you actually get it.
No, you're really going to like it. It's the zero product property. Okay? Is everybody good here? The zero product property states that if x plus 7 times x plus 4 equals 0, then x plus 7 equals 0 and x plus 4 equals 0. What it's saying is that each binomial in the parentheses, both of them are set equal to 0. That's your zero product property. So what you're going to do is you're going to set each of the factors to 0, and then you're going to solve for the variable. Okay, are y'all ready? Are y'all ready for this? Ready? Here we go. X minus 5 equals 0. Because that's my first binomial. My second binomial, x minus 1 equals 0. Well, how do you solve? It's a one-step equation. Plus 5, plus 5. X equals 5, plus 1 plus 1, x equals 1. Your answer is x equals 5, x equals 1. You'll see a lot of times they're going to write it like this. Either way, it's fine. These are called roots or solutions. Roots or solutions, okay? And I'll explain in a couple of weeks why there are two answers to something like this. So, let's do it again. Here, you're going to set 3x equal to 0, and you said x minus 5 equal to 0. So what do you do now? Divide by 3. X equals 0. Add 5 to both sides. X equals 5. So your answer is x equals 0, 5. See, I would take a whole homework assignment just like that. Setting it equal to 0 and finding two answers. Okay. Are we good? Okay. Let's do the last two examples and then we're done. I thought that stopped recording, but it looks like it's still going. Okay. Example, 2x squared plus 8x equals 0. So factor out the GCF. So the first thing we're going to do is we're going to factor out the GCF from each term. Okay? So 2x squared and 8x. This is going to be 2 times x times x. 8 is 2 and 4, which is 2 and 2. 2 times 2 times 2 times x. My GCF is going to be 2x. Okay, so I did the first part. Factor out the GCF. Now it says divide each term by the GCF. All right, that's where we do this. 2x squared over 2x plus 8x over 2x equals 0. Now I want y'all to pay very close attention because if you do and you understand it, you can actually skip a step. 2x equals 2 divided by 2 is what? 1. 2, that is an exponent of 1. So 2 minus 1 is what? So I'm left with an x, correct? Plus 8 divided by 2 is what? 4. And then do I have an x? Because I pulled there, you can pull an x out of each one, correct? Look at this. X is left over on the 2x squared. 4 is left over on 8x. So you actually don't have to do this long division part if you'll pay attention to that right there. You can just write it out. Okay, now you set each one equal to 0. 2x equals 0. X plus 4 equals 0. Divide by 2. X equals 0. Minus 4. X equals negative 4. So your answer is x equals 0 and x equals negative 4. See if we get the last problem in before I run out of memory. I'll come back. Okay. Last one. 6x squared equals 15x. The only trick to this one is you must move all the terms to one side